everybody, this is Miss Phoebus, and this is lesson 24, standard form of linear equations. I know you know slope-intercept form. This is a different form. So, question is, do you know what standard form is for a linear equation? It looks like ax plus by equals c. You've looked at these before when we were solving for y. So 2x plus 3y equals 5 is a linear equation in standard form. And we're going to use these when we write equations, especially when we're looking at systems of equations. We're looking where two lines will cross. So I can graph linear functions written in any form. And then I can also define where my intercepts are. We're going to look at how to find intercepts algebraically. We will show that we can rewrite linear equations from standard form into slope-intercept form, and that we can write a linear function in standard form to describe a relationship between two quantities. Here are our standards. We're creating equations. We're looking at intercepts. We're graphing and paying attention to intercepts, as well as building functions based off of different things. So we're writing equations and we're graphing equations. So from Unit 2, you learned how to find x and y intercepts from a graph. So you were looking at where do they cross on a graph. We're going to look at finding them algebraically. That means we don't need a graph. I do not want you to graph these. I want to see algebraic work. So here is how you're going to find an x-intercept, by plugging in 0 for y and solving the equation for x. To find a y-intercept, you want to plug in 0 for x and solve the equation for y. So we're going to make sure that we have our x and y intercepts labeled for our work. So we're going to have the x-intercept, we're going to have the y-intercept, and I want to see labeling, please. And what we're going to do for the x-intercept, we want x, we don't want y. So we're going to get rid of y by making it a 0. We're going to force y to be 0. And when we do that, negative 4x plus 0 is negative 4x. We can solve for x. Divide by negative 4, x equals negative 2. So our x-intercept, negative 2 is what we found for x, and then we plugged in a 0 for y. If we were going to graph that, negative 2, 0, would be right there. That is an x-intercept. Crosses the x-axis. Let's look at the y-intercept. For the y-intercept, we want y. We're going to get rid of x. How do we get rid of x? We're going to plug in a 0. All right, so we have negative 4 times 0, which is 0. 0 plus y equals 8. 0 plus y is just y. Y equals 8. So our y-intercept, because we have 0 for x, 0, 8 is our y-intercept. And we graph 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. That would be up here. That would be my y-intercept because it crosses the y-axis at 0, 8. So take out the x, plug in a 0. That will get you the y-intercept. Take out the y, plug in a 0. That will get you the x-intercept. So whatever the letter is that you're looking for, you're going to plug a 0 in for that other letter that we don't care about. All right, so negative 3 times 0 is 0, so x equals 27. So that would be 27, 0 as our x-intercept. And our y-intercept, get rid of x. 0 minus 3y is negative 3y equals 27. Oops, do this instead of erasing. Y equals negative 9. All right, and we have a y-intercept of 0, negative 9. So I want to see work. I want to see you try to plug in the 0 and get the x value, or plug in the 0 and get the y value. Let's do one more together, and then I'm going to have you do number 4 on your own. So number 3, we are going to do an x-intercept and a y-intercept. We're going to plug in, we want x for the x-intercept, so we're going to plug in 0 for y, So I have 5x plus 0 equals negative 40 divided by 5. X equals negative 8. So we're looking at negative 8 comma 0 as an x-intercept. And then 5 times 0, because we don't want x when we're looking at our y-intercept, plus 4y equals negative 40. So 4y equals negative 40. So y equals negative 10, 0 comma negative 10. All right, I want you to pause the video, see if you can do number 4 on your own. All right, check back and look at your work. Did you label? That's the first thing I want to see, because you're going to be taking a picture of this. I want to know what I'm looking at. Might be hard to tell. If you're looking at an x-intercept and you're plugging in 0 for x, then I need to tell you not to do that. So just let me make sure that I know what you're doing. Label, please. All right, so I'm doing an x-intercept. I plugged in 0 for y. We've got 9x equals 36. Divide by 9, x equals 4. So we've got 4 comma 0 as our x-intercept. How'd that go? All right, for our y-intercept, we're going to plug in 0 for x, x all for y. Oops, put in a negative 36. It's a positive 36. All right, 0 minus 2y is negative 2y equals 36. Divided by negative 2, y equals negative 18. So we've got 0 comma negative 18. How'd it go? Hopefully it makes sense. You're taking the value that you want, you're keeping it, you're preserving it. I want x-intercept, I'm keeping x. That means I have to get rid of y. And to get rid of, you're plugging in a 0. I love 0. 0 is my favorite. All right, I'm going to show you in these examples that the x and y intercepts might not always be very nice. So, and how to handle that. X-intercept, y-intercept, let's see, 3x plus 5 times 0 equals 8. That means 3x equals 8. That means x equals 8/3. You want to write that as a decimal or a mixed number, I guess you could, but I'm okay with 8/3 comma 0. So that would have to be something that if we were going to estimate, or if we were going to put it on a graph, we would have to estimate. And estimation is kind of iffy. There might be a better way to do it. Let's look at the y-intercept. That means I'm getting rid of x. So I have 0 plus 5y equals 8. 5y equals 8. So divide by 5. Y equals 8/5. So 0 comma 8/5. So not very pretty numbers, but the fractions are tolerable. Not too bad. All right, so I want you to try number 6. See what you come up with your x and y intercept. All right, make sure you've labeled. Did you label? If not, go back and label. If you're not labeling, you might want to make a note to yourself to label. Let's see, x-intercept, 2x plus 3 times 0 equals 11. So negative 2x equals 11. Divide by negative 2, x equals negative 11 over 2. So negative 11 over 2 comma 0. And then for the y, we're going to get rid of x. Then we're going to have 3y equals 11. So y equals 11/3. So 0 comma 11/3. So you can't have fractions. I don't want you to have a meltdown. If fractions do occur, they occur. But we're going to do our best to try to make sure that we are showing our algebraic work. Okay, so now we're going to graph in standard form. So one way to graph is to find the x-intercept, find the y-intercept, get them on there and graph. So we're going to do that for this example, but there is another way to do it as well. So we're going to graph 8x minus 6y equals negative 24. So to find the x-intercept, that means I plug in a 0 for y, and I'm left with 8x equals negative 24. So x equals negative 3. So I'm going to go on the x-axis to negative 3 and put a point there. I'm going to find my y-intercept. I'm going to plug in 0 for x and then solve for y. So I've got negative 6y equals negative 24. So y equals 4. On the y-axis, I go up to 4. And so I have 2 points. Now 2 points make a line, but I believe strongly that you should have as many points as possible. That makes a better line. So if you notice, if I start at the x-intercept and go rise over run, I can go up 4, right 3. So if I do that again, up 4, right 3. I can't do it again on the right, but I can go down 4, left 3, and I can build that slope all the way across. Remember, I like points all the way across. So this is one way to do it using your x and y intercepts. I should see work, though, finding your x and y intercepts. All right. The other way is to do what we did in lesson 4, where we solved for y. Remember, we moved the x, we divided by the coefficient in front of y, got y by itself, and then we're ready to graph. So that's another option. And I personally don't have a preference. Sometimes the intercepts are pretty easy to look at. Sometimes it's easier to solve for y. It just kind of depends. But you choose the method that you're comfortable with, most comfortable with. So the 3x, if I subtract it on both sides, I end up with negative 4y equals negative 3x plus 56. I like my x's first. And then divide each part. Remember, this is the one I was picky about, dividing each part by that negative 4. And then clean it up. Negative 3 divided by negative 4 is 3/4 x. 56 divided by negative 4 is a negative 14. And then you would graph that. So we're just practicing this solving for y component because that is a method that you can use if it's written in standard form. So let's look at 8. I'm going to subtract x. 2y equals negative x plus 9. Divide each part by 2. So y equals negative 1/2 x plus 9 over 2. If you wanted to put it as 4.5, that would work. I wouldn't go crazy with my decimals. Like if it's, 0.6 repeating, 2/3 is a lot better than 0.6 repeating. So kind of err more on the side of fractions. I think it would be helpful. All right, I want you to try 9 and 10. Pause the video. All right, number 9, we should be adding 5x. So I get 6y equals 5x plus 30. Those are not like terms. You can't combine them. Divide everybody by 6, each part. Y equals 5, 6x plus 5. So again, this comes back to lesson 4, something we've already talked about and done. All right, so I'm moving my x. If we get negative 5y equals 4x plus 35. Divide each part by negative 5. So y equals negative 4/5 x minus 7. So that's just a review of solving for y, and then you would use what we did in lesson 22 and graph using your slope-intercept form. So that's another way to get your standard form equations on a graph. So I'm going to do for 11 and 12, I'm going to do one of each. I'm going to do 11 as finding the intercepts. I'm going to do 12 as finding the solving for y. And then it's one of those things where you have to do a little bit of work on either of them. So as long as you're doing the right work, it should be okay. So for my x-intercept, I'm going to have x plus 0 equals negative 3. So that would mean x equals negative 3. So right there, x equals negative 3. There's my x-intercept. My y-intercept, I'm going to have 0 plus y equals negative 3. So y equals negative 3. So that would mean I have on my y-intercept, -3. And then you can count now if you do -3 over -3, or up 3, left 3, I guess that's a better way to say it. Up 3, left 3, or down 3, right 3, however you're looking at it, you're going to get a slope of -1. So you could fill in these points here. I like to, instead, I'm going up 3, left 3, I'm going to go up 3, left 3, hit another point, down 3, right 3, get another point. I'm just going to use those. You don't have to do every single up 1, right 1, up 1, or up 1, left 1, up 1, left 1. Right, again, I'm looking at the points. The line is nice to have. Actually, you need it. But if the line has a little bit of wiggle in it, that's okay. I'm looking at the points. All right, let's look at number 12. Number 12, I'm going to do by solving for y. So either way, I should have a little bit of work. So I've got -2y equals -x minus 6. Divide everybody by -2. I've got y equals 1/2 x plus 3. So I'm at 3. And then I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. I'm going to almost be in my work. Down, left 2. I want you all the way across the plane. Hey, I'm feeling really good about that line. There's a little bit of issue around 2, 4, but really feel good about that one. Nice and straight. All right, so that is what we're doing. We're doing x and y intercepts, or solving for y and then graphing in slope-intercept form. Again, I don't care. I don't have a preference. You figure out which one's best for you. Now, there will be some situations, like number 3, where one of the x-intercepts or the y-intercepts aren't that great. So what you may want to do is kind of play around with it, and then if you get weird fractions, you might have to solve for y. So for this one, if I did my x-intercept, I would end up with negative 5/3, and that I'm not really happy with graphing and estimating, so I'm going to just solve this for y. I think that'll be a little bit better. All right, so I've got -3/5 x minus 1. So there's my -1. I'm going to go down 3, right 5. And I'm going to go up 3, left 5. And kind of okay. Ooh, it looks like it crosses it. The line's not looking good. I'm looking at my x-intercept. My x-intercept should be a fraction, a little bit bigger than 1. So that first line that I drew wasn't quite the best. So anyway, you get the point. Get points on your line. That makes it a little bit helpful. Sometimes graphing or solving for y is better in your graphing than just doing the x and y intercepts. It's one of those things you got to play around with. I'm going to do the x and y intercepts here because you can do it with a decimal. So I'm going to do 10x. I know -3 times 0 is 0, so equals -15. If I divide, I end up with a -1.5, which isn't too bad to estimate. 1.5 is between -1 and 2. And then for my y-intercept, got -3y equals -15. So y equals 5. So there. So you can do estimation, it's not wrong, but it might be hard to figure out the slope. So it looks like I'm going up 5, right 1.5. So if I go down 5, 1, 2, 3, 4, 5, left 1.5, I'm about right there. So sometimes it can work. It's just one of those things you gotta play around with. But anything like 1/3 or 2/3 or anything like that is going to be hard to estimate. All right, so let's write some equations. We're looking at standard form where you have 2 rates and a fixed amount with no variable. So you're going to have where you're buying things, you're selling things, or you got different numbers of people in different groups or things like that. And so that's where your A and B come in, and then you will have something completely different, like a total cost or the total number of vehicles needed, or something like that, where you have no variable that is needed. That would be your C value. All right, so you're going to use standard form when you know two different rates and a fixed amount. And here's our example. You're purchasing plants and have $30 to spend. Now you could spend less than $30, but we're going to just go ahead and assume right now we are spending $30. We're blowing it all. Okay, so we are going to make sure that we spend all that money. So we're going to use the equal to bar. Now when we do this, I'm going to encourage you to define your variables, because you have two things going on. And if I just do x and y and look at my x-intercept and my y-intercept, I might not know what x means later or y means later. But if I make a little note that x means small plants, and this is the number of small plants that I'm buying, and y equals large plants, then when I come back to state what these values mean, because we're going to look at x and y intercepts, I actually know what I chose for x and what I chose for y. So you're purchasing plants and have $30 to spend. Small plants cost $2, so that means $2 for every small plant, so 2 times x. And large plants cost $6, so $6 for every large plant, 6 times y. When I go up to the register, they're going to add those together, and they're going to give me a total, and hopefully I've spent my $30. We're going to assume that we did. All right, so now we're going to look at x-intercept and y-intercept and bring them back to the context of the situation. So my x-intercept would mean I have 2x, I don't have any of the 6y left over, equals 30. So x equals 15. So what does that mean? That means I could buy, and x is small plants, so I could buy 15 small plants and 0 large plants, right? Because we plugged in a 0 for y. For my y-intercept, I don't need x. 2 times 0 is 0, so I've got 6y equals 30. So y equals 5. So that means I could buy 5 large plants and 0 small. Now what that means for us is we are looking at the extremes. What happens, because we can't buy negative plants. So the smallest that we can buy is 0. So we're looking at the extremes. If I don't buy any large plants, how many small plants can I buy? If I don't buy any small plants, how many large plants can I buy? And then everything kind of in between those values, those different combinations, could possibly work. So as long as I don't go over 15 small plants or over 5 large plants, if I look at a combination of other numbers in between those two values, then I should be able to spend my $30. So that's where the x and the y-intercepts come into play. So the x-intercept tells us how many little plants we can buy if we buy 0 big plants. And our y-intercept tells us how many big plants we can buy if we buy 0 little plants. All right, let's look at another one. So t-shirts at a flea market cost $4.50, and shorts cost $6 each. Darius has $54 that he can spend. Write an equation that models this situation. So the question is this discrete or continuous? Can we define our variables? Can we write an equation? Can we interpret the intercepts? So, can Darius buy a fraction of a shirt? So, like, is he going to buy an eighth of a shirt? I know some people out there buy really interesting clothing, but I don't think they're going to sell Darius like a sleeve of a shirt for less than $4.50. It's not going to work that way. So this is going to be discrete. Fractions are not okay. So let's define our variables. Let's let T equal the number of t-shirts. Now it's not the price because we know the price. And we're going to let S equal number of shorts. Now you can choose what variables you would like to use. You do not have to use X and Y, but just know that you need to be defining those variables. If you're picking two variables and you don't remember what one means and you switch stuff up later when you're explaining your y-intercept or your x-intercept or whatever, that's on you. You mixed it up because you didn't define your variables. All right, so let's look at writing the equation. So we know that there's $4.50 for each t-shirt plus $6 for each pair of shorts. I know S is not a good letter to use. Just try to make it look more S-y than a 5. And it's going to equal $54. All right, so we have a t-intercept now, and we have an s-intercept. So we don't have x and y anymore, we have t and s. So for t, oops, so for t, we would do 4.5t. We don't need 6 times 0 is 0, so equals 54. We're going to divide by 4.5. Grab my calculator. 54 divided by 4.5 is 12. T equals 12. So what does that mean? He can buy 12 t-shirts and 0 shorts. That's what that t-intercept means. And then we can look at the s-intercept. We don't care about 4.5t because it's 4.5 times 0. So I get 6s equals 54. So s would equal 9. So that would mean he can buy 9 shorts and 0 shorts. T-shirts. All right, so that's what's going on. We're looking at, is it discrete or continuous, or fractions okay, you know, that kind of thing. Again, is it stuff we're measuring? Is it stuff we're counting? Remember, we count with discrete, we measure with continuous. Defining your variables, writing an equation, and then looking at your intercepts and what they mean in the context of the situation. All right, concert tickets cost $15 for general admission, but $9 with a student ID. Hey, email me what your favorite band is. Who would you like to see in concert? Ticket sales totaled $4,500. Write an equation that models this situation. So let's look at our variables. So we know that we have two different types of tickets. So we're going to have, I'm going to let G be our general tickets. And we can use S again. We can, let's do that. S equals student tickets. Okay, we already know the cost of the tickets, so this is like the number of general tickets, the number of student tickets. All right, so the tickets cost $15, so 15G for our general tickets, plus $9 for our student tickets, and that should equal $4,500. So what we're doing is we're figuring out, if we know how much money, can we figure out how many tickets they sold? And there can be a combination of those, but we're going to look at our intercepts. You know, these are the max general tickets that we could sell or could have sold, and this is the max student tickets if we just sold student tickets. So that kind of idea. So I have a G-intercept, and I have an S-intercept again. All right, G-intercept, that means 15G, don't care about the 9S, equals 4,500 divided by 15. So G is 300. So it means that the concert, they could sell 300 general tickets and no student tickets. So that's one option. Remember, that's like an extreme. And then over here, our S-intercept, that would be 9S equals 4,500. So S equals 500, so they're able to sell more because the tickets are less. So they could sell 500 student tickets and no general tickets. All right, so hopefully it's coming together. Hopefully you're able to see the point of defining a variable, being able to write an equation, looking at our intercepts to figure out our extreme values, and making sure that we can interpret what those intercepts mean. You have a rectangular garden that measures 16 by 25 feet. So this, 16 by 25, we have 400 square feet. Now, this should be 8 square feet of space for tomato plants and 5 square feet of space for pepper plants. And so we're going to try to figure out how many tomato plants and pepper plants we could plant in that space. So we're going to define some variables. So I'm going to let T be the number of tomato plants. I'm going to let P be the number of pepper plants. And we're going to write some equations. So I have 8 feet of space for every tomato plant, plus 5 feet of space for every pepper plant, and I have 400 square feet to be able to put those plants in. So there's my equation. So I'm going to have a t-intercept and a p-intercept. So t-intercept, 8t, don't care about the p, equals 400. So t equals 50. So that means I could plant 50 tomatoes, or tomato plants, and 0 pepper plants. And then my p-intercept, don't care about the t, 5p equals 400. So p equals 80. Or I could plant 80 pepper plants plus 0 and no tomato plants. All right, so writing equations, looking at intercepts. Last one, your class is taking a trip to an amusement park. A small van holds 8 people, so I need to know how many small vans I need. A large van holds 12 people, so I need to know how many large vans I need. There are 144 students in your class. All right, so we're going to let S equal the number of small vans, and L equal the number of large vans. All right, so here's what I want you to do. I want you to write an equation using this information. Pause the video. All right, so does your equation look like 8s plus 12l equals 144? So, yay, you got it. All right, so then now we want an s-intercept and we want an l-intercept. Pause the video now, see if you can do an s-intercept and an l-intercept by yourself. All right, s-intercept, 8s equals, don't care about l, 144 divided by 8. 144 divided by 8 is 18. All right, let's look at our l-intercept. We don't care about s. 12l equals 144. So L equals 12. All right, now I want you to interpret those. Pause the video now. All right, that means we need 18 small vans and 0 large vans. Or we could do 12 large vans and 0 small vans. So those are if we're going one way or the other. Now, we're probably, if we are actually going to do this, we're going to use some combination of stuff in between. But Those are the extreme values. All right, guys, make sure you're taking your quiz. Don't forget that there is a quiz too. You have a test next week. Make sure you're asking questions. There is a open Google Meet today from 8 to 12. So make sure you're stopping in if you got any questions. All right, see you in the next video.